Good afternoon, everyone. My name is Thomas Gregersen. I work as a technical specialist in Northern Europe. I'm based out of Copenhagen, Denmark, so I'm going to do this in English because my Turkish is obviously not as good. I'm going to talk a little bit about BIM for the MEP engineering field. I'm going to jump just out into it. We are a little bit late, so let's start. This is going to be, or this is meant as an introduction to Revit MEP, how we can utilize BIM through Revit. And the idea is that I'm going to try and take you through how I've worked with some customers and seen how they've adopted BIM, both in the early design stages, how they collaborate with third parties within a project, how we can leverage that rich information that we have in the models to become better at making informed decision instead of just guessing or base our decision upon experience, how we work. And of course, I'm going to try and leverage that model that I built as we go on and use that to either do simulation or extend it into fabrication. But before I go on, I like to start with a little story. I've never been to Istanbul, I've never been to Turkey before, this is my first time. So when I arrived yesterday, I sort of thought, well, I have a couple of hours on my own, so I just want to wander around the city, see where I am, and get sort of a feeling, a touch with the city. So as you probably know, BIM is sort of a concept. If you ask one person, you get one answer, and if you ask another person, you probably get another answer. And as I was wandering around Istanbul yesterday, just around the corner here, there's a little shopping area, and apparently BIM to one of the shops down there is a mini market. So BIM's truly a definition, I think. I also wandered a bit around, because often when I get around, I sort of talk to people and they go, well, BIM equals Revit. In that same shopping area, there's a guy selling motorcycle equipment, and apparently Revit to him is something completely different. So I think Revit or BIM is kind of a definition, and I like to talk a lot about that. I think BIM is a lot about workflows, how to leverage the technology, how to utilize it to make better decisions or to work smarter, not necessarily harder. So for the next 40 minutes or so, what I'm going to try and do is take you through how I've been working with customers and seen what they've done to sort of leverage the rich information models that we build when we start working with software like Revit first, and then see how we can take that on to fabrication. So first of all, I'd like to talk a little bit about BIM inside Revit. I want to talk a little bit about load analysis, collaboration, how we can set up workflows and methods. I meet a lot of people, especially in Northern Europe where I come around, that says Revit is kind of an Americanized software. A lot of the simulations and analysis tools that we have in there is based upon standards that we're not working according to. So I'd like to talk a little bit about how we can leverage some of that anyway. And then I'm going to end up by sending out and talk a little bit about analysis and fabrication. So I don't like PowerPoints, and I think we've been sitting through PowerPoint after PowerPoint today. So what I like to do is just jump into the software and see if we can play a little bit around with these things. The screen resolution here is very low, so my dialog boxes are going to be huge. So I'm going to pan a little bit. Sorry for that, but I'm going to try and take you through. This is just a small building. It's never been built. It's an architectural design competition from north of Copenhagen, where I come from. Basically, for the MEP engineer, this is what it looks like. It's a lot of ductwork, a lot of pipes, and there's some electrical installations and cable trays in there as well. And we're going to see a little bit of each thing as we move forward in this particular project. So, to begin with, I like to talk a little bit about spaces and zones, because as an MEP engineer, what I really like to understand is how my building is going to perform before I start doing my work. And in the old days, what I did was kind of like, and then I performed what I would call an educated guess. Are you familiar with that? You know, as engineers, we make a lot of educated guesses. So basically, I like to base my educated guesses upon facts, or at least information. So I think spaces and zones is really, really useful to do that. And whoops, we just have to zoom a little bit here. And I think these spaces and zones can really help me achieve that. But when I start working with these, I face some challenges. First of all, when I do this, I need to have these spaces in my models. So, and we can just drag and drop spaces into the model and utilize the architectural. As I hover above my architectural, you realize that this is just a linked-in model. So even though I've linked in my model from the architect, and I know that you're probably sitting there saying, yeah, this is because he's working with an architectural model which is built in Revit. Yes, of course. If I want to leverage BIM, I need to have BIM background or data to leverage it. But I could do this with an IFC file as well, but it needs to be a three-dimensional model. But first of all, when I do this, what I get in is just information. I want to make sure that my spaces are named the same thing as my architectural spaces. And one of the nice things about working in an environment like Revit is that we can leverage that rich information from the architectural model just by using things like the space naming utility. So I'm just gonna let it run through and update my room numbers so that it is equivalent to whatever is in the architectural file. This is the first example of me leveraging information which is in an external file built by somebody else. I'm actually just importing the names from their file to make sure that we're consistent with our file naming. Very simple and small example of how we're leveraging that rich information in the models. Not just the geometry, but the information. The next thing I like to do is I like to zone up my model. I like to whoops again, gonna zoom out. I'm just zoning up so that I get a nice overview of which parts of my building I need to equip with the same equipment. And the good thing about, again, the BIM model is that by leveraging the information and color code my displays or my plan views by that information that I've put in, is that I can start produce, this is just the zones. I can start saying, well, let me look at this model depending on how I like to condition it. Which rooms needs to be conditioned in a certain way, which rooms needs to have air conditioning in them, which rooms just only need to be heated or cooled, etc., etc. And as I start to build in that information, I start to get sort of a better understanding of how my model is gonna look like. I haven't put anything in except spaces and some information. And the good thing is, as I start to model, imagine that I've been working on this project for a couple of weeks. I've probably put in some dock work. I could start doing design checks based on this. So if I take this part of my model, I've started to put in some dock work, and I can actually, based on the color of my zoning, look and see if my dock work actually matches the actual zones. So the green one here is supplying air to the gray area, whereas the light green one here is supplying air to this dark blue area over here. And by that way, I get sort of a visual fidelity feedback on my project, so I can keep track. Am I actually feeding the right zones with the right systems in my model? Just a little bit of, should we call it visual fidelity on the things? Of course, I could also leverage some of the building analysis capabilities in Revit. So if I jump to this one, I've utilized the analysis tool where I'm going to do a heating and cooling load. And I know people say, well, it's not really working according to our standards, but it doesn't really matter, because this is not a case of me documenting that this is how it's going to be. We're so used to, as engineers and people in general, that we're looking at the result I need to document. But in order to be able to document, I need to move in the right direction. And very, very early, if I use the built-in heating and cooling loads analysis capabilities, I can start getting an understanding of how much air am I actually going to use in various sites of the building. And if I zoom in a little bit on this foyer area, A0.62, we can, if I just scroll up here, you can see that there's a lot of, I need to exchange a lot of air in this particular part of the room. If I zoom in on the architectural drawing, you can see that that is the room leading to that big glass facade. So if I just scroll up here, that is the room just next or back behind that glass facade here. So I probably need to start having a dialogue with the architect about having some sunshades, or I could just jump back to my drawing here and go to my heating and cooling loads analysis. And if I jump into my foyer area here and click on the room, I can see that right now I'm just working with the building in construction site. If I click in, I can see that the exterior windows, they're just large double glazed, but with an absorbing coating. If I just change that and go into my building here and click on maybe a reflective coating instead, I could run another analysis, see what that brings me. Does I go up or do I go down? So that sort of serves as a basis for my dialogue with the architect, where we can try and find alternative ways of getting to lower that. I'm just going to cancel out here because time will definitely not allow me to do an analysis on stage here. But it's just feeding back information, and I'm now making informed decision instead of just basing my design decision upon my experience or whatever it could be. So, also I like to play a little bit around with dock layout. And basically, when we have objects, I'm just going to take this object and go, I want to create a similar version of it. If I click it somewhere here, just place it in real life, really what I like to do is make sure that this one fits my my ceiling grid. So, I placed it on the floor, which basically often happens. So I'm just going to put it up like this now, and go back. You see I have it here now, but it definitely does not fit in the center of my ceiling square. What I really like it to do is fit in that ceiling square. So I'm just going to drag it around, and at some point you can see my sort of cross, they highlight. So I'm just going to dump it because that means that this one is now, whoops, I dumped it wrong. I'm going to do this again. There. So now it's placed perfectly in the ceiling square, in the center of that ceiling square. And how come that it does that? This is not basic Revit. This is because when we created these families, we found ourselves constantly trying to measure these things in, making sure that they were placed perfectly. So basically what we did was, and I think this is one of the benefits of starting working with a parametric design tool like Revit, is that it allows me to build in functionality into my families that I really, really like. So basically what we did, we just added some lines here, which are reference lines or reference planes, and we made them sort of referenceable so that we can actually use these lines to position the actual equipment. And I think this has been to me. We're starting to manipulate the tools and working according to the process that we find annoying when we start to work. So easily placement out of these various types of objects that we have. I'm not going to talk too long about that, but just zoom a little bit down here. Then one of the obvious things I think that happens a lot when we work in Revit is that we like to do interference check. One of the obvious benefits of moving to a three-dimensional model is that we can perform these interference checks. But one of the challenges that I find is that how do I communicate these flashes? How do I tell them to the next one? Often the challenge is that As an MEP engineer, I understand how big I need the opening to be according to my equipment to pass through, but it's actually the structural engineer that needs to perform the opening because it could impact the load-bearing capabilities of a particular wall. So basically what we came up with was these little red squares. We call them opening requests. So after we perform the interference check, I'm just going to run the check for the sake of it. We're going to class walls in the architectural project with, in the current project, dots. I'm going to go there, okay. And basically I'm going to get a list, and when I zoom out a bit here, or select one of these, you can see that it highlights. But that's just giving me the clash between the dot and the actual wall. What I like to communicate is how big an object or opening do I actually need, but also because I probably need to put in fire dampers or something in these walls. So this is where I can start again leveraging the information in the architectural model, because if I just use a color coding from information in the architectural model where red is bearing and separating walls, blue is non-bearing and separating walls, and green is non-bearing, blue is non-bearing and green is bearing and non-separating wall. I can very, very fast see that these red ones here, I probably need to put in fire dampers in these rooms according to the standard I work with, whereas the blue ones I probably can just color them as I wish. So I'm leveraging the information that's already built into the architectural model to better understand how my design needs to look like. Then just after the coffee break, when we started on the breakouts, we saw the structural session. And my colleague was working very much on the copy monitor, so I'm not going to dwell too much about the copy monitoring functionality. But I think as an MEP engineer, this is a functionality that really sort of talks to me as I start to work with these things. Because I'm working with architects, and this is no offense against the architects. They like to put in highly detailed, rich, geometrical content into their models. As an MEP engineer, I don't really care about that. I just need to put in my connectors. So if we look at this case, I have two toilets. For the architect, that's two different types of toilets, because one is an ordinary toilet and the other one is a toilet for a handicapped person. So that's two different families. For me as an MEP engineer, these toilets are exactly the same. So I just need to put in connectors to lead the wastewater out, and a connector to put in the fresh water to flush the toilet. So what I like to do is I like to work with the copy monitoring functionality of Revit. And again, I'm just going to pick the copy monitor. I'm going to click on the architectural link, and I'm going to use the copy. I'm not going to go into the coordination settings. You saw that this morning. So basically, I'm just going to pick these objects, the sinks and the toilets, and I'm gonna put in my version of a sink and a toilet to work with. And if I jump up into 3D, zoom in a bit, because this is rather far away, I think. Let's zoom this up, something like that, and just swirl around. You see that I've put in sort of two-dimensional symbols of toilets and sinks, because what I'm really interested in is not the actual porcelain or the actual toilet. I'm just interested in where to connect to. It has three-dimensional connector points. So the connector point for the toilet is actually up on the wall, and the connector point for the wastewater is actually down on the floor. So I can put it there as I like to. And I leverage those points, so when I start working with my routing, my pipes, I can go to this. I like to work with placeholders. I find them easier to manipulate and move around. So when I go to my systems and start drawing, I usually start by drawing placeholders, because that allows me to and just route around with these particular placeholders. But you can also, if you don't like the placeholders, just route with a real pipe type like this. So I'm just going to continue my pipe right there and continue somewhere down here, just for the sake of it. What I also like about working with Revit as a system, as an MEP engineer, is that when I routed something, I might want to change that. So right now, this has been drawn as a copper tube or a pipe, and I might change that wanting to move into steel or something. So what I can do is just tap around, select the entire system, and I think a little bit of a change. So there's my system. You see I'm working there. I could, it's hard to see here. I could actually change my my type to this particular system, and I could go say, well, this is not a domestic water 2. I like to go with the domestic type 1, and I actually change now my copper tubing into a casted iron kind of system. And this is some of the benefits of working with BIM, is that I'm working with data, I'm not necessarily working with geometry. Time is running fast, so I think I'm just going to jump on. So, I've talked a lot about HVAC and piping. Of course, we can. I'm just going to finish that off by showing that. Of course, we can work with sloped pipes as well. I'm not going to do as much. I'm just going to turn around. This morning we heard that Autodesk would like our buildings turning a lot. But of course we can work with pipes that are sloping, and if we just look at it from the left, you can see that these pipes are actually running with a slope, so we can work with that. I'd like to talk a little bit about BIM for the electrical engineer as well. So first of all, I think that when we're running with things, as an electrical engineer, I often have a lot of objects running next to each other. So running with parallel ones are quite nice. So I'm going to do a parallel set of conduits, and basically what I like to do is I like to have one of these, and I like to have 3 of these, and I like those to be separated by -75. So because what I like to do is I like to put that to 1, and this, and that to 100. Just so that will give me 3 pieces of straight pipe just off my electrical panel. And basically, I like to go back in here and say this one needs to be 3. And that one, oops, 1.5, and that one there needs to be 1. And basically, I like to pick the entire system. So before I do that, I'm just going to do this one. It's going to make it a little bit easier. So back into my school. There. So now it's created parallel runs of my conduits all around. But the challenge is, if I pick this one, because that one and that one is in the same plane, I can easily make those connect. But if I try to do the same on that one and that one over there, I can't pick it, because they're not on the actual same plane. So basically what we like to do is we like to take this one and just say draw conduit, and just connect it to that one over there, and it automatically makes sure that we're connecting. Just a little check, and we can do the same thing to that one over there. And it will actually, if we take this one, as we start to move around, create these conduits that actually goes in one direction to another one. So routing and manipulating is really, really easy. But also, as an MEP or electrical engineer, I like to understand a little bit better on how my things are working. So if I go to this one, the lighting plan. First of all, if I pick this one, just drag it off. Wires in Revit are just two-dimensional annotations. It doesn't need to be three-dimensional to become intelligent. Right here I have one system. It is connecting to the lighting panel LP/PP 1.1, and this is going to, let's put faces on it a bit. It looks a little bit easier to do that. So we're going to name this not by using the panel name, but by using the face. So basically you can see that these one are all going to phase A1, and these one over here are all going to phase B1. If I can, that means that this needs to be a ground, a zero, and a hot wire. If I drag this one over here, connect. This one automatically updates. It understands that I now need to have two wires, because otherwise I can't connect to two different phases when I get to my panel board. So there is a bit of intelligence built into this, even though we won't necessarily drawing in three dimensions. Also, when I start adding, if I take this one and say I want to create similar, I'll just copy it over here. Basically, get in a few additional rows. That's not that really. Just delete these. And let's go down here, because what I like to do is I like to understand my choose first. So this is the downside of having a very slow display. So I'm just going to scroll down to my design check again. Now I'm going to leverage information again in the model. So basically what I've built here is a color coding scheme in my Revit displaying my logs values inside a space. So if we go over to this room here, and I take this particular lamp and I go, I want to create a singular lamp. As I put that into this space, you probably don't see a change, but as I put the next one in, you see that the color changes in this room, because now I have a different lux level. And if I put in an additional lamp, I'm going to get, or one more, I'm going to get to a different lux level. So I can use the information in my spaces to actually calculate the amount of lights I need to put in order to get to here. Also, if I go back and I start to annotate my object here, I'm not going to use a user, just put in. You can see that right now it's just putting in numbers on the lamps, because they haven't been connected, they haven't been set up in the system. So basically, if I pick this one, take this one, and go and say, I want to create a power circuit. I can do this on either plumbing fixtures or HVAC fixtures. I'm just doing the functionality on electrical fixtures. It's the same functionality. But basically what I want to do is I want to create a power circuit. I want to edit this particular system because I want that system to be fed by my lightning power panel 1.1, so I just plug in here. And I want this system to edit that, and I want to add to this particular circuit. And as I go around adding these are automatically edited to this particular circuit. They are attached to a face. And as I move into my power panel, or my lightning power panel here, I can go and say, well, I like to edit my panel schedule, because the panel schedule will automatically tell me that I'll probably make it a little bit very cheap for 10 minutes. Just fix that. So it automatically sums the value of what that I'm adding to this particular circuit. And as I'm adding these, I'm automatically summing them down here, understanding exactly how much voltage I need to supply to this particular panel in order to get the wide amount of watts and voltage to there. What I like to do as well is getting this model out, and the time is running fast, I'm sorry about that, but so we could dwell with BIM inside Revit, but to me it's a lot about information, that I'm leveraging that information to make design decisions, and I'm keeping up on that. I'm making decisions based upon what's there back to me. So what I like to do for the last 10 minutes is to take this particular model and ship it out to analysis. First of all, I like to take it out to simulation. So I've taken one of the rooms, just isolated that particular room, and what I like to do is just send this out to simulation. Just by clicking here, I can actually launch this in Autodesk CFD. And basically, what that will allow me to do is generate information about how this is how the temperature is changing as I start to pump in air into this particular room. I could make a section through this particular room to understand how the temperature is actually working in this particular part of that particular section, or I could start to understand how the airspeed is actually going inside this room. So we can start to understand better how this room could perform. There's tons and tons of other things I could do with computational fluid dynamics, like start understanding how comfortable people are in the zones, if a fire starts and things like that, how the smoke will spread in the area. But the main purpose is that I can start doing really accurate analysis on this. I'm just going to jump over to simulation CFD there and open up this one because basically this file is showing you the age of the room. Just let me get a minute. See if it comes back to life. The idea is that I'm over time tracing the air particles, so I can sort of get it looks a bit like spaghetti, isn't it? But the idea is that over time we're tracing the air particle and its temperature, and to see how it moves around the room from the exhaust to the extract of the supply of the system to the extract of the system. And understand how the air will then move around this room. Also, what I like to do is I'm just going to shut this one down and move into this particular one. From Revit, what we can do is we can move from a piece of equipment like this. I can go in here and I can actually export the center lines of this particular system. And with CAD MEP, I can import this system. But I'm not just importing the system, I'm actually converting it into something that can be fabricated. So each element, each hanger will automatically be placed into this particular system. And I get an understanding on what it actually takes of real life components to actually build this part of my HVAC system. When I've done this, what I can do is I can export this so that I can move into a product called MEP. And basically when I have the system in here, what I can do is I can start doing estimation. I can add information of labor rates, of overheads that I need to put on, and basically understand how much this particular system is going to cost me to actually build. And if I don't like the cost, I can try and take them down, spread them over the man hours, or spread them over my overhead to see how that works, in order to get a better price for my particular system. And what I also can when I'm in here is I'm just going to shut down my MEP version here. I go into this. I'm going to open up that same job in Conduct, because when I do that, basically now I import each and every part of this particular object or equipment string, and what I can do is I can now automatically nest this. So basically I'm putting information out on, if I click on this one, I'm putting information out, so how this should be unfolded and put onto sheet metal and be cut by a plasma cover. So I'm taking information from that rich design model and actually putting it into fabrication. And if I click here, I can actually write the NC codes. And basically that means that I can now start cutting this with a plasma cutter, setting it into fabrication, and do that. So I'm just going to jump back here and take this. CAD MEP or fabrication MEP is a series of AutoCAD-based applications, and today it's I've showed you 3 versions of these, or 3 applications: CAD MEP, which is the design and conversion of fabrication models; MEP, which is the estimation tool; and CAD, which is enabling me to send that rich information out to an actual machinery and get this caught. With that, we have about 5 minutes left of this particular session, and I'd like to take some questions if you have any. Don't be afraid of replying. Okay, no question? This was clear as ink? Okay, I think there's just me and this question series between now and coffee. So if that's it, I think we have a coffee break. Thank you very much.